So I've taken two multimeters, both set for the kilo ohm scale. So what you're looking at right now is this one says 4.34 thousand ohms. So 4,340 ohms for this one. And this one is 4.87 kiloohms, or 4,870 ohms. What these are looking at, what these two are measuring is, one is measuring from this one to this one, and the other multimeter is measuring the resistance from this pin to this pin. Okay, so it's sitting like this. I believe these two pins are being measured by this multimeter, and these two pins are being measured by this one. So as I turn the knob here on this other one, we should see these values change. So I'm going to go all the way to one direction. So what we see is this one says 9.07 thousand, so 9,080 ohms. I hope you can see that. I hope that it's on the video. This one is no ohm, or very little ohms. It's probably not open, but there's not much there. So if I go all the way the other way, this now goes to 9.06. So it's now, we're measuring the full resistance between this pin and this pin. And what that's really telling us is how much resistance there is between this outside one and this outside one. This is tapping. If the way this works is, inside here is a coil of wire with a very specified resistance. And on this pin is a wiper that rests or touches that wire somewhere as you turn the knob. So the connection between, so it goes, maybe for example, if this is hooked to 5-volt power, it would come in, see 5 volts here. If this one's hooked to ground, then because of Kirchhoff's law, it has to lose all 5 volts between this end of a load or a resistance and this end of the load. So if this is a light bulb, the resistance of a light bulb, then this would be the voltage drop across the light bulb. The same thing here in the potentiometer. The difference being that this is such a high resistance value that the current is super low, and there's no power coming through this. There's probably some heat being given off. There would have to be. That energy has to go somewhere between here and here. So it gets burnt off over 10,000 ohms of power. So really low current. You can put that back into Ohm's law and figure out, 5 volts at 10,000 ohms, how much current that is. But it's really low, 0.000 something. So not a problem. This wiper is now touching someplace between here and here. If it's touching farther at this end, it picks up the 5 volts. If it touches at this end, it picks up the 0. And anywhere in between is a linear, in this case, a linear drop of voltage as it turns around, or resistance. But we're going to show you what that does to voltage. This is a variable resistance device, but as we know, anything that has resistance is a load. This is a load. This is adjusting a voltage. The job of this thing, it doesn't do the same work as a light bulb, but this thing is a load on an electrical system. So what it does is, it's a very small load, but we're going to use it as a voltage splitter. We want to measure the voltage someplace between 5 and 0, because we have a device, namely this, our Arduino, that watches 5-volt signals. It knows when it's 0, it knows when it's 5, and it knows it can attach a digital number to any value in between 0 and 5. So what we're going to do is the signal, the voltage that we end up coming out of here with, is going to go to our Arduino and be read and math being done on it. Okay, so if it comes back at 1.7 volts, that means it's a little bit that way of halfway, which should be around 2.5 volts. So, and what we're going to do is, by us going back up and calibrating the position of this, we want this to we're going to feed this 5 volts with our lab scope, and we're going to adjust this until 2.5 volts comes out. Just so that electrically it's centered when it's mechanically centered. We could probably put some sort of device in that calibrates it. We could put another potentiometer in to adjust the voltage one way or another. Like, we could get this to be half voltage. For now, I'm just going to try to get it to be 0, 5, and 2.5. And do the math on 2.5 being centered, giving it a dead band to make it safe. When we get to the programming and the coding part and everything, I'll show you what I mean by the dead band, but I want the middle of this potentiometer to not really care what's going on. It's somewhere near center. I think if we try to keep it on exactly center, it's going to be hunting and moving around and always trying to find center. I think if we just say, look, get close, shut off. If you notice it move, then recenter it, and then shut off. I don't want I want this to be accurate, but not OCD. Okay, so I'm going to get the lab scope. Actually, when this is done, I'll hook the voltage to here. When I get this figured out, I'll get the holes drilled and everything, and then before I fasten them up, I'll show you what I've done to find the center of voltage here.